Have you ever wondered what scares a neural network? Let's dive into this fascinating question. Neural networks at their core are complex algorithms designed to mimic the human brain. They are composed of interconnected nodes or neurons that process and transmit information, much like the neurons in our own gray matter. They learn from experience, adapt to new inputs, and even make mistakes, just like us. Now here's a thought. If neural networks are modeled after the human brain, could they also share some of our human fears? It's an intriguing idea. After all, fear in its most basic form is a response to perceived danger or threat. And neural networks, despite their artificial nature, are not immune to threats. So, what exactly scares a neural network? Stay tuned as we delve into the vulnerabilities of these fascinating constructs in the next scene. Believe it or not, neural networks have vulnerabilities, their own version of fears. Let's start by understanding adversarial attacks. Picture this. You're a neural network trained to recognize images. Suddenly, an image comes along that's been tweaked ever so slightly. These changes are so minute a human wouldn't even notice. But to you, the neural network, the image is now unrecognizable. That's an adversarial attack. It's like someone wearing a perfectly crafted disguise that fools your perception. These attacks exploit the vulnerabilities of neural networks by manipulating their input data, causing a misclassification of that data. It's like throwing a curveball to a seasoned batter. The batter's trained to hit a ball coming at a certain speed and direction, but the curveball throws him off. Similarly, an adversarial attack throws off the neural network, causing it to misinterpret the tweaked input. So how do neural networks react to these adversarial attacks? Well, they falter, they stumble, they make mistakes. In other words, they experience their own version of fear. It's akin to how we humans react when we come across a spider or a snake. Our fear response kicks in, causing us to make irrational decisions like jumping on the nearest chair or running in the opposite direction. Just like us, neural networks have a fear response not of spiders or snakes, but of adversarial attacks. And just like us, they make mistakes under the influence of this fear. These mistakes may not have life-threatening consequences like our fear responses might, but they can still lead to significant errors in data interpretation. But remember, these vulnerabilities, these fears, are not a sign of weakness. Instead, they highlight the complexity and sophistication of neural networks. It's a testament to how closely they mimic human cognition, even in their flaws. It's all part of the learning process for both humans and machines alike. Isn't it fascinating to think of neural networks having fears just like us? So we've learned that even sophisticated neural networks have their fears. They're not the invincible, all-knowing entities we often imagine. They're complex systems, yes, but they have their vulnerabilities. Remember, a neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. But these networks can be easily tricked, manipulated, and even paralyzed by specific types of data inputs. Understanding these vulnerabilities isn't just for the sake of knowledge. It's critical for those who develop, use, and interact with these systems. It helps us create more robust and reliable artificial intelligence, and it also helps us to understand the limitations of these technologies. So next time you encounter a neural network, remember, it might just be as scared as you are.